Welcome to the fifth experiment of the high voltage electric testing 5 part study of the impulse voltage generator. In this we are going to evaluate the peak voltages, the peak voltage of impulse wave, front time and the tail time. Before going into the experiment, where do we use this? Where do we use these impulse voltages? Specifically speaking, for testing purposes we use them, for biomedical, for medical applications where X-ray units, electron microscopes are utilized. These high voltages are required. Along with that, in physics, nuclear physics, when we are working with nuclear physics area, we have electrostatic precipitators, particle accelerators, which require a kilovolts and megavolts of voltages, and also we transmit power at very high voltage for high efficiency and low losses. And simply speaking, by nature ways, where do we see these high voltages? The high voltages, a simple example is an lightning, natural lightning, thunderstorms. Before going into this experiment, let us analyze the characteristics or the different parameters of a impulse waveform. What do you mean by waveform? Impulse waveform: a sudden increase in a magnitude of the voltage and then sudden fall of the voltage will be there. We observe a peak point here, and then before this peak point, if we check the time, it will be a very short duration, and then after this peak point there is a sudden fall in the magnitude of the voltage. Based on this peak point, the time taken by the waveform to reach its peak value from the starting point is called as a front time, and also time taken by the waveform from the initiation till it reaches is 50% of this peak value. 50% of the peak value is called as a tail time. These two parameters we are going to evaluate along with this peak parameter, along with this peak voltage. For a standard front time, standard impulse, lightning impulse, it is 1.2 microseconds, while its tail is 50 microseconds. Maybe for plus or minus 3% tolerance can be observed for the peak value, and the tolerance for the front and tail time is something around 30% and 20% respectively. Then how to proceed? Before going to the into the experiment, let us identify our objectives. Our objectives is to identify the peak voltage, front time, tail time of the impulse high voltage. How are we going to do it? We are going to utilize an website, virtual labs, which is initiated by IIT Kharagpur, India, one of the best universities, best institution in the world. We are going to utilize this website, which we can do the experiment virtually. We need to click this. We will click it later. We will follow the simulation part once we end this session. Now, how to proceed? We are having in that website, we are having a simulator where we are going to, you will find a screen like this, where we are going to click this simulator to open the simulator exercise, simulation part. Now once you click that, this page will be displayed. What is this page? This page will consist of the charging voltage, CG capacitor, C1 capacitor at the charging voltage, charging capacitor we can say it as, we are having different resistors, and also the distance between the sphere gap here, that this is the distance between the sphere gap in centimeters. At different distances we need to evaluate the voltage, peak voltage and front time and rest time. To start the experiment we need to click this, and then we need to step by step we need to click on open ground switch, then we need to click on charging capacitors, and then we need to trigger the voltage which generates the impulse voltage here. When we click on trigger generator, a waveform will be pop up, and from that waveform we can evaluate a charging voltage, how much we have given, the peak voltage, how much we got, the front time and the tail time. Similarly, change the distance to 4, 6, 8 and 10 for different voltages at constant voltage. We need to evaluate the peak voltage, front time and tail time. What is the procedure? The procedure is set the charging voltage say 20, and then the input parameters, namely charging voltage, ground capacitance, tail capacitance, front inductance, front capacitance, tail resistance, displace all these values. Set that we need to set it in the picture that has been shown is in default values. Set the distance initially at 2 centimeters. Click start, then click on the open ground switch from IVG simulator, then click on the charge capacitor. After clicking on this charging capacitor, a pop-up window will be there where you can observe a impulse waveform. If you study this waveform, you will find the peak voltage, the tail time and the front time. We will observe this. Now let us move to the website. I will give the link of the website. See, yeah, I will give this link. This is the study of the impulse voltage. Introduction. In the first page, in the first tab, we are having an introduction of the high DC voltages, impulse voltages. These are the different impulse conditions. And then if we go to the theory part, explanation about the tail time and the front time. This is the waveform. This is the time for the tail time, and this is the front time. This is the front time, and this is the peak voltage. This is the peak voltage. Different denominations here we have. These are the objectives, out of which we are going to evaluate 3 objectives. One is peak voltage, front time and the tail time. Coming to the simulator tab, here see, observe this, we are having IVG simulator. We need to click this. We will click this and we are going to set this voltage. In theoretical class, we did a problem when you are studying high voltage in problem number sheet 2, problem number 7, where we have evaluated the impulse voltage, peak voltage of an impulse voltage. Along with this, we have evaluated front time and the tail time of the impulse waveform, where the voltage that we have utilized was 100 kilovolts. We are giving that 100 kilovolts. Set this to some values according to the problem what you have. I am setting to the default values here, and I am setting to start with, let us set the distance to 2. Let us set the distance to 2 centimeters, and now press start. I am pressing start the experiment. I am starting this experiment. When I start this experiment, it has been asking us to open the ground switch. See, here we are having the ground switch. Open the ground switch. You can observe the ground switch is open, and then charge the capacitor. Where are the capacitors which are in red color? Here we are giving power supply to this. They are getting charged. The color of the, see, it is charging. The color of the capacitors will change now once it is fully charged. No, it is already charged. If it is red, means it is in charge condition now. Now we are going to trigger it. Trigger means whatever voltage has been stored in this capacitors, we are going to apply it on this sphere cap. Trigger it. See, we are going to apply the voltage, and then this waveform is generated. What is the peak voltage we have observed? See, here the results have been, a waveform has been popped out, and here the peak voltage is 11.46, the front time is 0.5, and tail time is 50.5 microseconds. See how to observe this. How much we got? 11.46. I am pointing out on this waveform, it is 11.46. The same peak voltage we got it here. See, 11.46, and the tail time at the 50% of this peak value. What is the 15% of the peak? 11.46 is something around 5.5. How much it is? The distance from this initiation, from this point to this 5.5 value or 5.5 value, is this value to this here is tail time is something around 50.5 microseconds. It is observed here to this magnitude, the duration from the waveform generated to this point. Okay, anything issues? Now to start again, the next value, however, is change this value to 4 and then restart the experiment. Open the ground switch, charge the capacitors. See, the color of the capacitors have been changed. Trigger it. It means once it gets in contact, the circuit is closed, and whatever voltage is there, it is subjected on the test material. And then again, the peak voltage is same, but the tail time has been 50. If you get the same tail time, write the same tail time. Now if you want to save this output, save the graph here, and it will be stored in a PNG format, and you need to write a report with the help of these graphs. Okay, at different what we can say, at different charging voltages, one format is to change the charging voltages and get this at different distances, at constant distance, at different charging voltages. You can get this output different. You can get this peak voltage, front time and tail time. And another form of doing this experiment is keep this charging voltage constant and change the distances. Whatever you observe, put it in a report and submit it. With this, we are going to end this session. Thank you.